Now, we have recently been dealing with the binomial probability distribution, or one in which two events can. What happens if we have more than two events that can occur? For example, we might have test scores, or we might birth weight of babies. There's so many things in which two events, and most natural phenomenon follow what we call the normal distribution. This is also referred to bell curve, because it has that nice bell shape. And what it means is most people fall on the average, and then as we start to deviate from the average either up or below, we get less and less people. Now, for example, if you were doing test scores, we might say most people scored a 75, and then as you got up into the 80s and the 90s, the scores would start to drop off. We wouldn't have as many people who got those scores. And the same on the other side. As you started to go down into the failing grades, you wouldn't have as many. So this makes this nice bell shape. And what's important about the bell shape is the average is always in the center or the highest point. So for this particular diagram here, the average is my center point, or what we can think of as of the bell curve. Each one of these bars represents a standard deviation. This is one standard deviation above the mean. Is subtract the values of two bars next to each other. I tend to do the positive values, like 5 minus 2 gives me a standard deviation of 3. You can do any values. 8 minus 5 is 3. The width of those bars is 3, which means the standard deviation is 3. So remember, the mean is the highest point, and the standard deviation is the difference in the bars, or how wide the bars are. Now, what happens if you have to draw out your own value? What do we have here? We have monthly cell phone charges are normally distributed with a mean of 62, so that would be that mean of 62, and a standard deviation of 18. Sketch a normal curve for the parameters. Now, I have this really cool part of Microsoft Word because I paid for a tablet because I teach math, and that's what I do. It was totally worth it for me. You guys probably don't have this cool inking feature, so drawing the normal distribution might be a little harder. There is a draw function in Word. You may draw it out by hand and scan it or photograph it if you'd like, or you may go ahead and use a different program. Paint is a nice one that comes with Microsoft computers. It's preloaded onto all of your Windows machines. You're going to find it in the accessories area, and it's just called Paint. And this gives you a brush in which I can draw a normal curve, just like I'm drawing by hand with your mouse. Now remember, this said, I'm going to go back and look, I think the mean was 62, and the standard deviation was, oops, it was 18. Shh. So the mean, or the center data point, is 62. Now we do usually draw 3 standard deviations. So 1, 2, 3. I'm going to add 18 and get 80. And then I'm going to add 18 again to get to the next standard deviation. I didn't draw my curve very big. 98. And then I'm going to go ahead and add 18 again to get to my last one. I'm going to draw a little arrow in there. I left myself a little bit more room. Now, am I looking for you to be mathematically perfect and have a sketch that's absolutely symmetrical and all your bars are exactly the same width? Well, you should see from my picture that the answer to that is no. My picture is not mathematically perfect. It's a rough sketch, and as long as you get the idea that the mean is the highest point and you get your 3 standard deviation bars in there, even if they're not exactly equal, like you can see mine aren't, we've got a normal curve. And I'm going to go ahead ahead and do part B on this as well. Shade the region that represents the proportion of cell phone plans that are charged less than $44. $44 is right here, and less than is going this way. The plans that are less than are going this way. So I'm going to go ahead and shade that in. And you're more than welcome to just have to copy paste one curve over than doing this twice. Then I just want to select, it's a paint tool, my whole curve. I can copy it. The tool is right here next to the paste button. It's a little tool you push. I can go over to my Word document and I can paste. Okay? And you know, for part B, I might just say, see above, shaded in red. Okay? What are two interpretations for, oh, that should have another 4 in it. The area under the curve to the left of x equals 44 is 0.1587. The first thing I could say is the proportion of cell phone users whose bill is less than 44 is 0.1587. That's what that means. The area represents the proportion or the probability of selecting a cell phone user randomly whose bill is less than $40 is 0.1587. So portions have the areas have two interpretations. The proportion 0.1587, or the number 15.87%, have a cell phone bill less than 44, and it's also the probability of randomly selecting them. For example, I could look at the area. The area is 0.1908. I don't know what the situation here is, but I know that because it's shaded to the right, the proportion of being higher than 280 is 0.1908, and the probability of choosing something higher than 280 for whatever the situation is 0.1908. So areas represent proportion and probability.